Welcome to this video. In the previous video, we studied about solutions, suspensions and colloids. In this video, we will study the separation of components of mixtures. As we know, most of the substances around us are found in the form of mixtures. A variety of methods are used to separate the components of these mixtures. But you may be wondering, why is it required to separate the components from the mixture? Separation makes it easy to obtain and use information about each component of the mixture. The heterogeneous mixture can be separated by simple physical processes such as selecting by hand, filtering and sieving, etc. But can we separate all the mixtures by physical processes? For example, can we separate ink into its components by some physical process? No. Special techniques are used to separate mixtures such as ink. Let us now study some of these techniques. First of all, we will learn about evaporation. Let's try to understand it through an activity. Fill half the beaker with water. Now, place the watch glass on the face of the beaker and put some drops of ink on the watch glass. Now, start heating the beaker. What do you see? We can see that evaporation is happening from the watch glass. We will continue heating the beaker until it evaporates. After a while, you will see that there is no change in the watch glass. Then we will stop heating it. Is there any residue left on the watch glass? Yes. We can see that the blue component, dye, appears as a residue on the watch glass. So, according to you, which substance has evaporated from the watch glass? Absolutely correct. Water? So we can now conclude by this activity that ink is a mixture composed of water and color components, in which water is a solvent and color is a solute. And we can separate the solute from the solvent in mixtures such as ink by evaporation. Let us now learn about the second technique of separation, centrifuge. Take milk with a little bit of whole cream in a vessel. Now, try to separate the cream from milk by filtering it with a sieve. Did you succeed in it? No. Why so? In fact, the particles of cream present in milk are so small that they come out of the filter container. Then, how can we separate mixtures such as milk with cream? Now, let us take this creamy milk in a test tube. Now centrifuge it for 2 minutes with a centrifuge machine. What do you see? When the centrifugal device is rotated rapidly, heavy milk particles settle down and light cream particles remain on top. Particles of creamy milk, blood, wastewater, etc. are too small that it cannot be separated by filtration, but can be separated by centrifugation. Now let us learn about the technique of separation of a mixture of insoluble liquids. In this activity, we will put a mixture of kerosene and water in a separation funnel. Now, we'll leave it undisturbed for a while. What do you see after a while? Yes, after some time, separate layers of water and oil are formed. But why so? This is possible because water and kerosene are insoluble liquids. Kerosene, being lighter than water, rises upwards to form a separate layer. And due to the water being heavy, it remains in the bottom layer. Now, we can open the stopcock of separation funnel carefully and remove the bottom water layer into a beaker. Close the stopcock as soon as the oil reaches the bottom. In this way, we can see that the liquids which are not soluble among themselves can separate into different layers according to their density. Therefore, with the help of the separation funnel, mixtures of insoluble liquids such as water and oil, molten iron and slag, etc. can be separated. Let us now learn about the next technique, sublimation. Take a mixture of salt and ammonium chloride in a ceramic cup. Now cover this cup with a funnel upside down and close the open end of the funnel with cotton. Now heat the ceramic cup slowly using a burner. What do you see? As the cup is heated, the vapor of ammonium chloride rises upwards from the cup, and after some time, this vapor starts to settle on the cool surface of the funnel. Keep the ceramic cup warm until the vapor stops coming out of it. Now, turn off the burner and scratch out the solid ammonium chloride in a bowl. In this way, we separated the mixture of salt and ammonium chloride. But how was this possible? This was possible because ammonium chloride is sublimable substance that converts directly from the solid state to the gaseous state upon heating. By this activity, we can conclude that to separate such mixtures that contain a sublimable volatile component from a non-sublimable impurity such as camphor, naphthalene and anthracene, the sublimation process is used. The next separation technique is chromatography. Let us understand this by an activity. Take a thin layer of filter paper. Draw a line with a pencil 3 centimeters above its bottom edge. Now, place a drop of water-soluble ink in the center of the line with the help of a sketch pen. Allow this drop to dry. Now, take some water in a jar and keep this filter paper in such a way that it stays just above the surface of water. Now leave it undisturbed. What do you see? Different colors are seen on the filter paper. How did this happen? Why did this happen? As the water moves upwards on the filter paper, it also takes the dye particles along with it. Often the dye is a mixture of 2 or more colors. The color component, which is more soluble in water, rises faster, and thus the separation of colors becomes possible. This method of separating components from a mixture is called chromatography. It is a method used to separate solutes that dissolve in the same type of solvent. For example, in separating pigments from natural dyes, separating drugs from blood, etc. The next separation technique is distillation. Let us try to understand it through an activity. Take a mixture of acetone and water in a distillation flask. Put a thermometer in it. Now, arrange the device in this way. Heat the mixture slowly and carefully observe the thermometer. As the mixture heats up, what do you observe? Vapor distillation of acetone appears to rise in the flask at approximately 56 degrees Celsius. This acetone vapor passes through condensation, it starts condensing and again accumulates in the beaker in the liquid phase. In this way, we can separate the mixture of acetone and water by distillation. This was possible because a mixture of acetone and water is a mixture of two miscible liquids that boiled without decomposition and have sufficient difference in their boiling points in between 56 degrees Celsius and 100 degrees Celsius. To separate a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 K, fractional distillation process is used. You may be thinking that by fractional distillation method, we can only separate the mixture of liquids. But can we use the distillation method even if we have to separate the gaseous mixture? Let us know about this by the example of air. Air is a homogeneous mixture and its components can be separated by fractional distillation. Suppose we have to separate oxygen gas from air. To do this, first let us arrange the devices in this way. We have to separate the other gases present in the air to get oxygen from the air. To obtain liquid air, the pressure on the air is first increased and then air is cooled by decreasing temperature. This liquefied gas is slowly heated in the fractional distillation column, where all the gases separate at different heights according to their boiling points. Now, finally, the last separation technique is crystallization. Take about 5 grams of impure copper sulfate in a ceramic cup. Dissolve it in minimum amount of water. Filter out impurities. Now vaporize the water with a solution of copper sulfate to obtain the saturated solution. Cover the solution with a filter paper and leave it undisturbed at room temperature to cool throughout the day. What do you see? We can see that there are crystals of copper sulfate in the ceramic cup. This process is called crystallization. Now you might be thinking that which mixtures can we use to separate by using this process? We can use crystallization to purify salt. For example, when receiving salt from seawater, it may contain many impurities. The crystallization method is used to remove these impurities. Crystallization is the method by which pure solids in the form of crystals are separated from the solution. And do you know, the crystallization method is preferable over a simple evaporation method for the following reasons. 1. Some solids disintegrate or some scorch when heated, like sugar. 2. Even after filtration, some impurities can remain in the solution if the impurities are dissolved in the solvent. These impurities can contaminate the solid when evaporated. Thus, according to the nature of the mixture, we can get pure substance by using any of the methods we have learned. Friends, today we studied separation of components of mixtures.